In this video, I want to talk about finding the zeros of polynomials when we need to do some factoring. And remember, the zeros are just the x-intercepts of our polynomials, so where it will cross the x-axis. And for all of these problems, we'll usually be given some type of equation which we can factor. And once it's in factored form, we can use our zero product property to figure out when the polynomial will cross this x-axis. And for the Khan Academy exercises, you'll have an interactive grapher where essentially you'll just plot these points by clicking on it. So let's rewrite this equation since we're going to need to do some factoring. So p of x is 3x to the third minus 3x squared minus 18x. And the first step with factoring is you want to look for a common factor. And notice that each of these terms are divisible by 3, so we can pull a 3 out. And each of these terms have at least one x in it. And we can't pull out more than one x, since then we'll end up with fractions. So we'll have to look at the lowest number of x's and factor that one out. So we can factor 3x from each of these terms. And remember, factoring is essentially we're dividing each of these by 3x. And it's the reverse of the distributive property, or at least for finding a common factor. So the 3's cancel, we just get 1, and then x cubed divided by x, well, there's 3 x's up top, we divide by 1x down below, and so 1 in the top and the bottom will cancel. And just so you can remember that one, we have x times x times x up top, we're dividing by x, and so one of these can cancel out, and we get x squared. You're essentially just subtracting the exponent by 1 with this property. So here we have x squared. Then for this one, the 3, when we divide it into negative 3, we get negative 1. And then x squared divided by x, we just subtract that exponent, since 1 in the numerator and 1 in the denominator will cancel out. So this second term is just minus x now. And dividing minus 18 by 3 would be minus 6. And then x divided by x is 1. And you can always check this by redistributing, just to make sure that you're doing this correctly. So from here, we have a quadratic, which we can likely factor further into a product of two binomials. And since the coefficient on x squared is 1, we know these first terms in each of these binomials, these will multiply to give us our x squared. So we just have to figure out what the numbers are. And we know that they're going to multiply to negative 6. And those same numbers, they're going to add to the coefficient on x, which in this case is minus 1. So we're looking for numbers that multiply to negative 6. So that could be minus 1 and 6, minus 6 and 1. It could be minus 2 and 3, or minus 3 and 2. And they also have to add to negative 1. So that would be this pair here, this minus 3 minus 2, or plus 2. And again, you want to check your work if you're not completely sure, or if this is a test and you need to be right. So you can check it by just redistributing here and multiplying these two binomials together, and you'll see you end up with this quadratic here. So once we've gotten this in factored form, remember, we're just finding the zeros. So we're just finding when our polynomial is equal to 0. And like I mentioned in the beginning of the video, at this point, we'll just use what we know as the zero product property, where if any of these expressions here, the 3x, the x minus 3, or the x plus 2, if any of them equals 0, then the entire polynomial is equal to 0, since 0 times anything is 0. And so for this monomial out in front, this 3x, if we just plug in 0, for that one, then you'd have 0 times negative 3 times 2, which is 0, since 0 times anything is 0. If you use positive 3 for this one, you would get 0 here. And if you use negative 2 for this last one, then you would also get 0 here. So the zeros, or the roots, or the x-intercepts of our polynomial, are at 0, positive 3, and negative 2. And so we can mark those. 0, positive 3, and negative 2. And in a later video, we'll learn how the graph will continue from here. It's a cubic polynomial, so it's going to generally look like a cubic. And you'll see once you learn about end behavior that it will go up and just kind of weave through these. Though the maximums and minimums here, these are harder to get. You really need tools from calculus to be able to deal with that. But again, that's all in later videos. For now, you just want to understand where these zeros are and how to plot them.